So number 6 here, using the synthetic division, you find that 1/2 is a 0 of the given function. The quotient then for the synthetic division array is 2x squared plus 2x minus 12. Show how to write the factored form using all integer coefficients. So we have to take this portion here and factor as best we can. So we can factor out a common term 2. We're left with x squared plus x minus 6. From here we can factor two terms that multiply to get -6 and add to get +1. It'll be a +3 and a -2. So this is just this underlined portion. If we think about the function as a whole, again we said that 1/2 is a 0, so now we can add that portion in. So that means we'd have x minus 1/2 and then the x plus 3, x minus 2. So this is where we can take the x minus 1/2 and rewrite it, pulling the denominator here in front of the x, and then minus the numerator. Still have the x plus 3, x minus 2. Now, since this whole thing is being multiplied by 2, if we want just the factored form of the function, we're just going to get rid of that 2. The 2 is just, x plus 3, and then x minus 2. The 2 is just showing that it's a multiple of this basic function. So it's still going to have the same zeros. It's just going to be stretched. So the original basic factored function would be this. And then 2, again, is the 1 multiplied by 2 is just a multiple of this function. Okay, we want to find the zeros of this function. So first thing, figure out how many possible zeros we can have. This would be 3. Now we're going to plug it in. X to the third plus 3x squared minus 13x minus 15. So again, we're looking for zeros, so that's where they cross the x-axis. Got 1, 2, 3. That's good for us. Let's make sure they show up in our table. I think there were 2 to the left of our x-axis. Yep. So we've got a value at -5, at -1, and at 3. So our function is going to be x plus 5 times x plus 1 times x minus 3. Possible number of zeros, 3 possible zeros. Let's pull it up. So our function here is x cubed and then minus 3x plus 2. Graph it. Well, we can only see 2 zeros here on our function. So let's see where those are. One's to the left and one's to the right of our x-axis, y-axis. Oh, wrong direction. So one's going to be at -2 and one's at 1. So the calculator zeros we have are at -2 and 1. So we still need to find this third zero. Since we know those are two factors that do exist for the function, we can use synthetic division to divide those factors out and see what's left. So I'm going to use the -2, use synthetic division, and do some dividing. So coefficients for x cubed would be 1, x squared is 0, -3 and 2. Let's bring down the 1, then we multiply. -2 times 1 is -2. Now add 0 and -2 is -2. Multiply. -2 times -2 is +4. -3 plus 4 is 1. -2 times 1 is -2. Add, those get to 0, which is what we'd expect since we know it is a factor. So now we can take our coefficients here to come up with our new function. So I have x squared minus 2x plus 1. Well, this does indeed factor. This factors two terms that multiply to get 1 and add to get -2 would be x minus 1 and x minus 1. So this is showing us there's a repeated root. We already have 1 as a factor. We just happen to have 1 as a factor twice. So our rational zeros would be at -2, 1, and 1. So then our function is going to be x plus 2, x minus 1, x minus 1. Or you could write it x plus 2 and x minus 1 squared. 7c, first we look for the number of zeros, x cubed, so we could have up to 3 zeros. We plot it in our calculator. We've got x cubed to the third, there we go, minus x squared minus 5x minus 3. Graph it. Let's see what we got. So we can see 2 zeros here. One's going to be to the left of the y-axis, one's to the right. We have one at -1 and at 3. So again, we're going to use some synthetic division. I'm going to pick -1. I'm going to write my coefficients. Multiply -1 times 1 is -1. Adding, we get -2. Multiplying -1 times -2 is +2. Adding to get -3. -1 times -3 is +3. Adding to get to 0, as we'd expect. Rewriting our new function, we have x squared minus 2x minus 3. Two terms that multiply to get -3 and add to get -2. We have x minus 3 and x plus 1. So that means the -1 term is occurring twice. So rational zeros are at -1 at 3. So we'd have x plus 1, and x minus 3 for our function. Largest number of zeros we could have is 3. Now we want to graph it. We got 2x to the third plus 7x squared minus 53x minus 28. Graph it. You can see 1, 2, 3. Let's check it out. 2 of them to the left of the y-axis, 1 to the right. Well, I'm only seeing 1 here. It's at -7. You know, there's 1 to the right. And at 4. So those are our calculator zeros. What that's telling me is that my other zero is probably going to be some kind of fraction, since it's not showing up strictly in my table. So I still need to find out what it is. So I want to use the synthetic division again here. So I'm going to use 4. We'll have 2, 7, -53, -28. Bring down the 2, multiply to get 8, 15, 60, add to get 7, 28. There's my 0. So this means my function is 2x squared plus 15x plus 7. This actually does factor. If you think about it, since your first term is 2x squared, your only option is that you have to have 2x in one factor, 2 and x in the other one. And we need two numbers that multiply to get 7, so it has to be 1 and 7. Our middle term here is a positive 15, so that means our 7 is going to have to be multiplied by the 2. So we have to put it over here with the other term, and then the 1's going to be over here. So that means our zeros, one that we didn't have already, is going to be at -1/2. So we already have -7, we already have 4. Our other one is at -1/2. When we write it out as a function, we'll get the 2x plus 1 and the x plus 7, and then the term, the x minus 4. And this is our function here.